So welcome back. And in today's lecture, we're going to talk about observation in something called MVVM. So just quick announcements. Homework three's soft deadline is due today at midnight. And the mini project, which is called Class Planner, will be released tomorrow night. And then here's the agenda for today. We'll first review how data flows through our SwiftUI views. And then we're going to review the difference between value versus reference semantics that we touched upon or learned in lecture two. Then we're going to talk about this framework called observation that allows us to, or gives us at state behavior, observability behavior to reference types. Um, and then we're going to talk about what macros are. And then finally, we're going to end with this concept called MVVM, which is a way of how we could architect our apps. So to review data flow, we kind of explored this concept of, in our SwiftUI views, which are structs, right? How we can have immutable data within them. So for example, here we have in this content views body, we have this button, and whenever we tap on this button, we increment num taps by one. And num taps is declared initialized here within the struct content view. Now, when you do this, you get this error where it says self is immutable. And the reason for this is that you cannot mutate a struct from within the struct. Okay, so you cannot mutate the struct, in this case, this numTaps property, within content view. So regular structs can't, or properties cannot be mutated within their own structs. So how do we mutate these properties? The simple answer is that we basically add this property wrapper called an add state to numTaps. And what that does is that it allows the variable allocation to be handled by SwiftUI. So SwiftUI is going to manage the memory and lifecycle of this variable. Uh, and what also that gives us is that whenever this numTaps property changes or its value changes, SwiftUI will kind of like announce it to whoever uses numTaps. In this case, this button, and we call this, this button has a dependency to numTaps because the button, right, this view uses numTaps. So we say that button has a dependency to numTaps. And okay, so whenever I click on this button, numTaps increment by one, and then SwiftUI would say, okay, whoever using numTaps, re-render yourself to update yourself to reflect the new value. And it's efficient. So what I mean by that? Well, we only re-render views that are using the at state variable dependencies. So if this body was more complicated, that we have a bunch more views and they're not using num taps, then SwiftUI is smart enough to say we don't really need to re-update those views because, well, they don't really use num taps at all, right? It's only this button. So just gonna update this button only. And so if you have a really complex view, this is really efficient. And so here, we'll click on this button. What happens? Well, we're gonna increment num taps by one, and now since button has a dependency to numTaps in this case via this text view, view of the button. And what it's going to do is that it's going to re-render the view itself because this button has a dependency to numTaps, right? And then we're going to click on it again. Now it's two. And then we're going to re-render the view, or in this case, this button exactly uh, to show the new reflected value of numTaps. Okay, so we have seen how we can have mutable data within our structs via an add state. And now let's talk about kind of how we can pass this, how we can pass values to subviews. And not only that, but where our subviews can mutate the values in its parent view. Okay. So here we have this kind of example where we have content view, we have this incremental button, and this incremental button takes in this num taps. And it's the same code of this button, but now we kind of abstracted away, refactored it into its own struct called incrementable button. And then what we want to do is that when we tap on this button, we want this num taps to change, right? But here we have an issue. We have two at states. Now, remember that state declares a source of truth. So that's where the actual data actually lives. Now, when you do this, okay, what happens is that you have two sources of truth. So you have two places where the data lives. And that's not good because we only want one place where data actually lives, where incrementable button can reference that data. So if we do this, this is incorrect. Again, the goal here is to sync up incrementable buttons num taps to the one in content view. However, since incrementable buttons num tap is in at state, initializes a new place in memory. So now we have two places of num taps, and that's inconsistent. So to fix this, we introduce a new property wrapper called an at binding, which allows you to read and write from or to a source of truth. And remember, a source of truth is basically an at state variable. So we have, again, a binding works when you have a parent and a child relationship. Okay, so the parent view is the content view, and the child view is the incrementable button. So what we want is for incremental button to read the value of num taps in content view, but also update it, right? When we click on the button. And so to do this, we basically add an at binding property wrapper to the parameter of the subview or child view. And then at the call site, when we pass in num taps, we're not passing just num taps. We're not just passing an integer. We're also passing the binding down into incrementable button. And to denote that we're passing a binding, we prepend the variable name with $sign. So now in incremental button, we can read num taps, right? And we also can write back to it. Cool. So at state, right, our views are structs, they can't be changed within themselves. So if you want to change, mutate properties within a struct, you need to annotate that variable as an at state. When you do that, it hands off property control to SwiftUI so that it manages the memory and lifecycle of the view. And whenever the value changes, SwiftUI will tell, all the views that depend on that variable to re-update itself. And this is great for simple properties that belong to a specific view. For example, let's say you're showing a sheet, right? You might have an at state variable that keeps track of whether that sheet is on or dismissed, or maybe you want to keep track of a variable that displays like an editing modal, for example. And we usually use, or when we're using an at state, we know that usually it's kind of data pertaining to that view itself, right? Other views don't really care about that variable. And so usually to be safe, we annotate those variables also with a private keyword to limit the access scope of that variable to just the file or just the struct itself. And of course, it declares a variable as a source of truth, where that's where the actual data lives. This is the typo where it's a safe slide, but again, at binding is simply when you have a parent and child relationship where you have the data actually lives in parent, right? That's the at state, but you want the child to also not only read the value that's in the parent, but also write back to it. And to use at binding, we annotate at binding to the variable property in the child view, and then in the parent view, when we're passing that argument into the child view, we add this $sign notation to the variable in front of the variable to denote that we're passing a binding rather than an actual type of the variable. Cool. So that is a quick review of data flow. Now let's kind of quickly review over value versus reference semantics. So there are two ways, right, we can represent an object or kind of describe what an object is in Swift. Or in other words, how we can declare a data model to represent abstract objects, real objects, and so forth. One of them is structs, another one is classes. And the main difference between the two of them is that structs are value types, or they conform to value type semantics, versus where classes they conform to reference semantics. So here, for example, we have this person struct, and here we have these two uh, instances, right? Kaylee, Kaylee 2. Now, if you notice that Kaylee 2 is assigned to Kaylee, right? So, and then we mutate or change the occupation of Kaylee 2 to be account rather than singer. So when we print these out, we should expect that they should be different. Why is that the case? Well, because, oops, because structs are, they conform to value type semantics, whenever you assign a new variable, or sorry, when you assign to a variable to a new variable, it copies the data. So Kaylee's, uh, the Kaylee person here, right, this instance, it gets copied to Kaylee too. So there's now two kind of persons, right? Two instances now that are separate. And so when we do this, we're only modifying the occupation on the new copy that we created. And now also for structs, for value semantics, when you pass a, I guess, argument into a new function, that value also gets copied. So you're working within the function, you're actually working a copy of that variable. So whatever you do in that function just stays within that function itself. All right, so for classes, again, same piece of code, but we expect them to be the same. Why is that? Because classes conform to reference semantics. Kaylee 2, instead of copying, it just simply points to the original Kaylee. So we call this that Kaylee 2 has a reference to Kaylee because again, it's just pointing to that data in Kaylee. So here, here's a way just kind of visualizing the um, the value versus reference semantics. So here we have structs, right? What we do, Kaylee 2 equals Kaylee, the data gets copied, and then we're mutating the occupation property on Kaylee 2. And then for classes, right, where we just pointing to Kaylee 2 points to the Kaylee object here, and we're just mutating the occupation to now be singer. So now both of them, we do Kaylee occupation and Kaylee 2 occupation. They both reference the same value, which is a count. All right, so that's a quick review of value versus reference semantics. Now let's talk about what observation is. So when we want, so again, we use at states with instructs. Instructs are value types. But if we wanted to have the same functionality where we want to have observable properties within a reference type, so what is a reference type? Like, for example, within a class. So if you want to have at state observability behavior for your properties in a class, that doesn't work if you just simply apply at state to those properties. And so if you try to do it and you mutate some data, it doesn't automatically update the views because at state doesn't work with reference types. So again, if we have this piece of code here where we have this class student and we have this at state property, and whenever we want to, here when we press on this button, we try mutating or changing the student's major, it just simply doesn't work because student is a reference type and that doesn't support observation or observability behavior, right? That we've seen when we use an as state with a value type. Because yes, we are changing the student's major's value, but it doesn't notify the body to re-render itself or to update itself, because it just doesn't support that observability behavior. And so observation is a framework introduced in iOS 17 in dub 2023. And what it does is that it basically allows you to mark a type as observable, a reference type as observable. And what that does is that it allows you to track changes within an instance, its properties. So whenever a property changes, whoever in the view is accessing that property, it can know to re-render itself to update and reflect the new value. And the main idea is that it allows reference types, like classes, to act like at state on value types. And again, sort of like creates a source of truth using at state. And so, like I mentioned before, like dependencies, right? A more technical kind of definition or kind of behavior, how it works is that a view forms a dependency on an observable data model object when the view's body property reads a property of the object. Okay, what that's saying is that if if the view itself right, within the body is referencing a property on this observable object, then we say that this view forms dependency to that object. If not, well, the view doesn't track any dependencies. And if a track property changes, then SwiftUI just re-updates the view, right? And if other properties change that the body doesn't read, like I mentioned before, the view is unaffected and avoids any unnecessary updates for performance reasons. And you could also support tracking of computed properties that make use of an observable property. So if a computed property is simply a property that its value is derived from other properties. And so whenever, the properties within that computer property or changes, the computer property also change. So some subtleties that we want to understand is that observation tracks changes to any observable property that appears in the execution scope of a view's body property. And it can also share a observable object to other views. So what that means is that you might have this is talking about if you have a parent and child relationship. And you can imagine a view hierarchy is quite complex, where it's very nested, right? What you could do is that from the parent view, you could have the actual instance or the observable object, and you could simply pass it down through the view hierarchy, where the bottommost view can read and also write back to that um, object itself. And if views in the middle, right, of that view hierarchy, if they don't use those, if they don't form a dependency to that observable object, SwiftUI is smart enough to not like re-render or like re-update itself. It just again, if the bottommost view actually farms dependency to the object or actually uses a property on that observable object, SwiftUI would just know to skip all of the intermediate views in between and just re-render the one down below. So now we figured out how we could add at state, right? We can use this framework observation to add at state behavior to reference types. There's also something called a at bindable, and at bindable is simply a binding for observable objects. So in places where a binding expected, you can wrap a model data using at bindable, which directly mutates observable object properties and can exist outside a SwiftUI view. So if you want to support bindings for observable objects, you could just simply use, at binding var book. And in this case here, right, book is an observable object. And again, I'll show you how we can make this an observable object later on. But we this looks like to be a child view, right? We're passing this book from a parent view, and we want to pass the title property of book as a binding into this text, right? Uh, Parameter of text field. And what this does again is that when we're typing on the user is typing in this text field, we're actually mutating the title property of this book. Okay. So this allows us to, gives us bindings to properties and pass it into, again, in this case, a text field where we could just pass in this string binding into this text parameter. All right, so that is observation. And well, once we see a concrete example of how we could use observation, I think it's going to make a lot more sense. All right, so next let's talk about macros. And the reason why we're talking about macros is that to use observation, we're actually using macros. And so what a macro is that it's simply a way to compactly write code, attach it to, for example, class, a property, or whatever, and in a really lightweight syntax. And all the code that you want to declare, you want to add functionality to the class or property, it gets expanded when the program or app gets compiled. So let's take a look at actually how code gets run on a computer. Again, this is really kind of general kind of overview of how it works, but your program or code is just simply text. It's just simply a sequence of characters and strings, right? But to a computer, it's like I have no idea what this is, right? So it needs to know, or you need to convert this text-based program into a language that a computer understands, which is assembly. So the next step is to put this text or put your code into a compiler. A compiler basically is a program that translates code, which is text, into machine code, into assembly, binary, it just depends, but usually it reduces it or converts this code into more low-level language like assembly. And then afterwards, it gets translated into machine code, which is like binary, which is like ones and zeros that your computer can actually understand and run on your CPU. And after all of that, you get back an executable where you can actually run the program on your computer. Now, macros, like I mentioned before briefly, is that they allow you to add or generate hidden code. So you can use this really lightweight syntax to simply add code that's, again, it's hidden, but it'll expand during compilation. So the difference between macro, again, it has a similar syntax with this at sign, is that macros, again, they expand during compile time, whereas property wrappers, they execute during runtime. So these macros are getting ran dynamically when the app is running. It gets injected before the app gets ran. Whereas property wrappers, right, with the app state, because app state, what does an app state do? Well, it manages memory, it manages the lifetime of the property itself. Well, that happens when the app is running, when it's dynamic. So that's the main difference. And then an important idea is that it never modifies or deletes your current code, right? When you add a macro, we don't want or have this, add side effects that change the current implementation of what you have in the code itself. But we want you to just simply add or extend functionality. So it never modifies or deletes your code. Um, and we can see that to add observability to a reference type, we use this macro called an add observable. So we simply, add observable to a class, and that makes it observable. So here's a kind of picture of how it kind of works. Now, again, it's very complicated because the compiler doesn't really work with text, you know, exclusively text itself. What it does is it kind of translates that source code text into a data structure like a tree, which we call it the abstract syntax tree, where in this tree we have these different nodes, that correspond to expressions. And again, during compilation, at the very beginning, we have this kind of program or process called a preprocessor, whose one of its jobs is to expand those macros. So what it does is that it takes this tree and inject or add nodes into this tree to expand the macro. And then it goes onwards to the next compilation phase. So, right, so just at the very beginning of the compiler, we have the preprocessor that takes in, this syntax tree, inject nodes into the syntax tree, and that's basically equivalent of adding code into your program. So to basically create or add observability function to a reference type, you could simply annotate a class with this add observable macro. And when you click on it and you click on edit, I believe it's expand macro, you can see all of the injected code that's being done when you actually compile the app. Again, this is all Apple code, basically code that Apple wrote that mutates this library manager and to create or add observability. And it's so simple. For us, we just simply do add observable and that's it. All right, so that's macros. Now let's talk about MVVM. And this is very important because it's one of the ways of how we can architect our apps. So MVVM stands for Model View View Model, and it's an architectural pattern that facilitates the separation of UI from the backend business logic to the actual UI itself. So again, there's three parts. We have the model. The model is simply your data models, so your structs, your classes of how you represent data in code. And then we have our views. Our views are SwiftUI views that we know. And then we have something new called the view model. Now, our view model is sort of, I like to think of as like a manager that manages instances of your models. So you create instances of your model objects, model types, right? Those are actual data. Those live in the view model, and the model view model exposes public functions, properties that the view can access, and vice versa. For example, let's say you're fetching data from the server. You can have a view model that has all this, fetching logic. And let's say this app is, for example, like a grocery store app, right? We might have a property that has a list of grocery items, and this view ha basically has an instance to this view model, and in a list or somewhere, it's kind of looping or kind of displaying all of those grocery items in this view model. So another example is that let's say we want to make like a game app, right? We have players. Those players are represented, or it's their data models are represented by struct. We have, of course, our game view itself, the actual UI to display the game. And then we have a view model. In this case, we title it Game Manager because, again, view models are basically managers, right? Where it contains or has a reference to like a list of players, objects, and let's say, we're playing a game like Battleship or something, right? When the user presses a button, that button calls a method on Game Manager where it does some kind of mutation or kind of updating some data to reflect the new game state. So, how do we convert an existing project into MVVM? Well, the models will stay the same because, again, that's not the main point of MVVM. Your models are now kind of abstracted away, right? If you have, it's kind of its own entity, right? But it's still kind of describing what the data is, right? Now, the main part is that we move all business logic from reviews into our view model. So, like I mentioned before, let's say you're making a lot of network requests or you're doing a lot of computation of data. Well, that data should just live in the view model, right? The kind of the functions, all that kind of processing, the logic, business logic, right? That should be in the view model. Your views should only be responsible for showing UI, right? It should be just focused on the UI part. Not it doesn't need to worry about where do we get the data, how do we, process the data, how do we clean the data? Like that's not the main job of a view. And so we have the at state variables in views where they're only pertinent to the views themselves, nothing else. So we should only have at state variables in our views that are just for that view itself. For example, like again, like I mentioned, the if you have an edit button that shows a modal or to show a sheet, um, and etc. And now our view model should be a class, right? It conforms to reference semantics so that we can pass a reference to our subviews rather than copies. Now, what do I mean by that? Now, if you imagine our view model conforming to our value types, we pass that variable or that value object around. Every time we pass it down to a child view, that gets copied. Well, that's problematic because we want to have a single view model, a single manager where all our views reference that view model, right? To keep the data in sync. So if the view model gets copied around, then we have, multiple places where the data lives, different states, and that's not very congruent, right? It's kind of, and then, some views may have reflect this kind of state, and then some other views reflect another kind of state. And so it's just kind of you know, very disorganized, and your UI just ends up not working at all. All right, so let's talk about how we can actually share model data through a view hierarchy. So there's a couple ways. One of them is what we said before, where we just basically pass an object down to its subview explicitly, right? And this is very convenient if you really have a shallow view hierarchy. If you just have, three, maybe even four layers, right? Parent has a child view, that child has a child view, and so forth, right? It's simple, it does the job. But if you have something more complicated, you can actually pass or inject the object into the view's environment. And so what a environment is that every view has an environment, which is basically metadata of that view. So you can get, for example, information about whether the device is in landscape mode or portrait mode, or whether it's in dark or light mode. And you can get those properties from the view's environment, And you can also inject objects into it. And so you can inject it once in the parent view, and all of its subviews automatically have access or can get the object from their own environment. And the reason for this is because child views inherit their parent views. So, for example, let's say we have a really long view hierarchy of like 10 views. We can inject an object, an observable object, into the parent view's environment, and then all of its subviews automatically have access to the their parent's environment, which is where the object is being injected to. And so instead of passing down one by one by one by one by one, we could just simply inject the object into the parent view's environment, and then at the very bottom, we can just basically get it from its own environment, which is really cool. So environment allows SwiftUI to pass system-wide settings to views, and it views an inherent environment from its parent view. And if you want to actually override the environment down some point in the middle, down to its subsequent child views, you can use something called the at environment modifier to do so. All right, let's take a look at a demo of how we can use add observable and how we can use MVVM. Okay, and this app basically does networking requests, and it simply fetches all of like the BART stations here. And I can click on a BART station and it gives me like a map of that BART station and like that description of that city or whatever. So here's Concord, I wonder if I could let's see here. And again, I'm clicking option to do a two-finger pan. Here is Berkeley, right? So that's this app. And what it's doing is that it's basically fetching or making network requests. Like we haven't learned that yet, but it's doing all that network. It's calling the BART API and fetching all of that data. And here you can see I have this BART models file. And again, it looks very complicated, but it's just I fetch all of the data from the API and I'm basically changing it into our structs. Um, so you can see here a BART station has a name, it has an address, has a county, has a state, and so forth. Okay. And again, don't worry all of this. It's just basically converting it into our structs, right, our classes, whatever. Um, so here within this content view, again, this content view is just basically what the UI you see here. It has private at states pertaining to the camera position of MapKit. Again, we're using MapKit, which allows us to display this map here. And it has an optional selected station so that when I select a station, I can basically show that detail view. And here I have a list of stations, and these are just a list of BART stations, right? Now here is where we actually doing the fetching. Again, you don't need to understand this. Just think of this function. You don't need to understand every single line. Just think of this function as we're fetching the stations from this API. All right, that's all you need to know. So here is where we're basically getting all of the BART stations, right? And it's within this content view. And here in our station detail view, we have a binding to that selected station. So that when I click on it, it's able to also read the value, right? Um, and here we're also fetching the data, the detail view data for that station itself. And yeah, so that's basically it. So how do we convert this into MVVM? So what we do is that I like to create a new view model. So what we do is you do import observation. So observation is a framework, you have to import it. And I create a class. Okay, so I'm gonna call this I'm gonna call this my BART station manager. Okay, so this is my class, and again, this is gonna manage. It's gonna hold the logic of fetching the stations for me. So I need to make this class an app observable. Um, and the reason is because I want to have a variable here, a property that holds all of my stations. So what I'm gonna do is I'm gonna go to my content view, and you see how I have these stations right here, right? This content view, this view does not need to know about the stations. Its only sole purpose is to display the UI. So I'm gonna move this out of here and I'm gonna put it to my view model. Okay. So I'm gonna plop it down here. Now we can't use an add state here. An add state only works with it works only works with views, right? So I'm gonna delete that. I'm gonna make this public so that I can access it in my views. So we have a empty array of my BART stations. Cool. So now let's go back to my content view. And as you can see, stations here, we can't that's not my view model. So we'll work about that later on. So now we see we have our fetch stations, right? We should bring that out and put it into our view model. So I'm going to create this, put that function there. Nice. I need to also import foundation. Foundation is simply a library that contains all like Swift things like URL. Again, don't worry about the logic here. All you need to know is that this function fetches our stations. That's all you need to know. Okay, so we have a function here. Now let's actually fetch the station itself, right? So how are we doing the fetching? We're doing it actually here. So in SwiftUI, we have this view modifier called onAppear. So when this view appears, you can do something. And in this case, we're fetching the stations. Again, don't worry about what a task is. Just know that we're just calling this fetch function, or fetch stations function. Okay, that's all you need to know. So there's also a on disappear for those who are interested, but we could remove that. And on our view model, when we create our BART station manager, we could run fetch stations. So how do we do that? So whenever we want to do something, when we create an instance, we use the initializer. So we don't need to take in a stations. We just basically call fetch stations. So what this code does is that it will call fetch stations and fetch all the stations and populate it in stations here. It's going to populate it into this array. So cool. So that's basically, I think that's what my view model is. Now, of course, we want whenever station updates or mutates, I want content view to be able to observe this property and refresh its view to reflect the newly fetched stations. So how do we make the stations observable to a view? Well, since we imported observation, we could use this observable macro. So we tack it on to this class, and I could right click and I could say expand macro. And as you can see, it injects all of this stuff into this code, which allows for us to observe stations in our views. Okay, we don't care about any of this. Let's just hide macro expansion. Cool. So let's actually create an instance of BART Station Manager. So let's go back to content view, and I am going to create um, um, we're going to create our instance here. So I'm going to do state private var view model, and I'm going to create the instance here, BART Station Manager, like so. So now, instead of stations, right, we brought stations into View Manager. So we just do view model dot stations. Okay. Now, here in station detail view, um, let's see. Um, okay, cool. Nice. Okay. So let's say I want, for example, maybe I want station detail view to have access to this view model. Okay. How do we do that? Well, one way is to basically physically pass that object into station detail view. So like this, I can do var view model
BART station manager. And then here in station detail view, you physically pass it in. Uh, right, like so. You do view model. Like so we're passing view model into station detail view. And so if station detail view needs to use view model, we could access it here like so. Another way is via its environment. So let's say pretend station detail view has a lot of subviews, right? And you want like the bottom subview to have access to view model. What we could do is that we could basically, delete this and inject the object into station detail view's environment. So we could do this by using the environment view modifier and passing that observable object, this view model. So we're injecting this view model into the station detail view's environment. So now station detail view can get access to it from its environment. So how do we do that? We use this at environment, and then we provide a key path, like a property. In this case, we supply the type of the object, which is station, BART station, BART station manager dot self. Dot self is the type. So we're basically saying I want to get the observable object whose type is BART station manager from your environment, please. And then we basically can get it here, like so. And there it is. So now we can get access to view model within the station detail view. Now pretend station detail view, right, has another subview here, called I don't know, station station detail view, right? Now in station detail view, it has access to the view model because station detail view inherits the environment of station detail view, which already includes this view model. So again, let's just uh station detail view view, right? I could just basically copy and paste this line right here, and then just paste it into here because I have access to this view model in station detail view's environment. Okay. So you can think of, if station detail view has another subview, I could also have access to this view model because it's being injected into its environment and every subview inherits it. So that's a quick look at how two ways you could pass data. One, by physically passing it as an argument. The second one is injecting it into the view's environment, in which its subviews have access to it because subviews inherit its parent view's environment. Okay. Technically also we should move selected station into the view model. But since we're running out of time, we'll just stop that there. But hopefully you could see how we can use at observable and MVVM together, right? Your view model should be a class, it should be observable class. You create it in your root view, and you can basically pass it into your subviews, and your subviews can access it. All right. Does that sort of make sense a little bit? Okay, cool. We kind of briefly reviewed the difference between structs and classes. Structs are value semantics and classes are reference semantics. And then for us to allow at state observing functionality for reference types, we could use this framework called observation, or we could use a macro, which is in this case an at observable that we attach to the class, and which it makes its properties observable. And we learned how we can separate separations concerns, where we separate the business logic from our actual UI views. So MVVM stands for model, which is our data models, view, our Swift UI views, and the view model, which is a manager that acts like a manager that has instances of those models that our views can interact with and from. And we could see that we could pass data to views, where we could pass from one subview to another, and we can inject an observable object into the view's environment.